When developing new or improving existing functionality in Autodesk Powermill, our aim is to make the benefits as far-reaching as possible. In the most recent releases, you will have noticed that a lot of development effort has been focused towards improving toolpath safety and quality, helping you produce the accurate parts you desire in a robust environment that builds confidence that your programs will run successfully. For Powermill 2020, we have built upon this by revisiting toolpath calculation performance. Enhancements have been made throughout Powermill 2020, with significant improvements to model scanning processes, making efficiency gains in some of the algorithms, and allowing better use of multi-core processors. All of which adds up to Powermill 2020 seeing some dramatic improvements in calculation and simulation speeds. In this tutorial, we're going to make a direct side-by-side comparison between Powermill 2020 and Powermill 2019.2. In this instance, both versions have been run independently on the same Lenovo ThinkPad P71 workstation laptop, which has a quad-core Intel Xeon E3 processor, 64 gigabytes of RAM, and an NVIDIA Quadro P4000 graphics card. For this example, we are using a composite layup mold of approximately 1100 millimeters by 470 millimeters by 450 millimeters in X, Y, and Z respectively. Let's put Powermill 2019 and Powermill 2020 side by side. We will begin by activating the first of the uncalculated toolpaths, a steep and shallow semi-finishing toolpath, and accessing the settings. Let's begin the calculation whilst discussing the settings. For the steep regions, the toolpath is set to cut in any direction, with the shallow regions set to climb mill using a 3D offset strategy with smoothing and centerline switched on. The toolpath has a tolerance of 0.01 and a steep and shallow step down and step over both set to 1 millimeter. Since this is a semi-finishing operation, we have left 0.5 millimeter of stock on the part, and collision checking is enabled for the 30 millimeter ball nose tool for the operation. Note how in this test, the toolpath in Powermill 2020 finishes 25 seconds quicker than in 2019, an improvement of 22%. Moving to the second toolpath, a constant Z finishing operation, we will again activate the toolpath and open the settings and begin calculation. This toolpath uses the same 30 millimeter ball nose tool, but now we have set 0 thickness on the part since we are finishing. We have set the same tolerance and step down as before, but we are limiting the toolpath within a shallow boundary. Again, you will see the toolpath in Powermill 2020 calculates 12 seconds quicker than in 2019, saving 33% of calculation time. The third toolpath is a raster finishing operation with similar settings to that of the constant Z toolpath, only this time we are cutting inside the boundary. Again, we will activate the toolpath, access the settings, and hit calculate. The difference in calculation speed for the raster finishing toolpath in Powermill 2020 is even more significant than that of the previous toolpaths, and we must wait 23 seconds before the 2019 toolpath has finished, an improvement of 67%. The final toolpath we will look at is the corner finishing operation. For the final time, we will activate the toolpath, access the settings, and press Calculate. For this toolpath, we are using a 10mm ball nose tool to machine the corners, using the 30mm tool as a reference. Whilst calculation for this toolpath is closer between versions with only 4 seconds in it, Powermill 2020 still finishes first, saving 16% in calculation time. And the speed improvements do not stop at toolpath calculation. Toolpath simulation also benefits. Here we have activated the roughing operation in the setup, and we have selected the option to simulate from start. With the ViewMill simulation switched on, we are simply going to press play. This roughing toolpath uses a 50mm diameter tool with a 6mm tip radius. We are using that full 6mm radius as the step down value and have set a step over of 42mm. This toolpath uses an offset style, leaving 1mm of thickness remaining on the part. And since this mold is for a low volume composite part and would likely be made of modeling board, the cutting has been given the freedom to go in any direction. Once again, Powermill 2020 is significantly quicker than Powermill 2019, simulating the roughing operation 33 seconds quicker, a saving of 32%. The simulation code is also used behind the scenes in the NC program verification, so this should also appear faster. This encourages the use of verification as part of the normal programming process, further boosting confidence levels that your toolpaths are safe to run on your machines. Looking at the results in this particular test, the overall time saving using Powermill 2020 with both calculation and simulation resulted in a reduction in time of over 30%. Of course, the differences will vary between projects depending on toolpath type, project complexity, and so on, but you should expect to see speed improvements in many areas of Powermill 2020. Whilst developing high-quality, safe toolpaths will always remain our top priority, Powermill 2020 manages to reduce calculation times without compromising on your core needs. By reducing calculation, simulation, and verification times, Autodesk Powermill 2020 will have you cutting your parts even faster.